Okay, so now we have a similar problem. If two stars differ by 8.6 magnitudes, what is their intensity ratio? So essentially we're going the other way, and last time we were using this math formula over here, and now we're going to use this one. And I do want to bring up one more point on this, in terms of which formula to choose when considering this. It's best to kind of think of it as you're at the core of something and you're trying to get out. And you'll notice we get the IA over IB, and we're always treating them as one variable anyway. So let's just treat them as one variable now. Instead of using IA over IB, I'm just going to use I. So I is going to be equal to 2.512 to the power of, and instead of using MB minus MA, just going to use M. Alright, and I'm going to do the same thing over here. So it's going to be 2.5 times the log of I is equal to M. So we can see here that the first thing we have to do is the centerpiece, plug in the variable, then we find the log of that variable, then we multiply that by 2.5, which gives us M. And with here we plug in M, we take 2.512 to the power of M, which gives us I. So what I always want you to think about is getting from this innermost part to the most outer part when deciding which formula to use. Alright, so here if we're given magnitudes, 8.6 magnitudes, we have been given this M. Okay, I'm back. Had to leave for a moment. So since we have magnitudes here, that's what we're going to work with. So we can simply plug it into this formula. It's going to be 2.512 to the power of, well, not M. We know what M is. It's a magnitude, which is 8.6. Alright, and that gives you the intensity. So this ends up being, let me punch it into a calculator. Oops, what's that? That's my other video. Alright, so that was 2.512 to the power of 8.6. Oh, we get a 2755 point, I'm going to say 0.3. That 5, make it more cleaner. Alright, so that's what we get in terms of an answer to this. So and let me just do it my other way, which I'm actually more comfortable with anyway. 10 to the power of 0.4 times 8.6. For those who don't know, 10 to the power of 0.4 is the same thing as 2.512. They're equivalent. Alright, so I do 0.4 times 8.6 first, then take all that to the power of 10. So let me use handy dandy calculator. I'll get the same thing. I know that. So that's 0.4 times 8.6. Well, it changed entirely by one whole value here, and you can see the danger of estimation. So as long as this is not in astronomical units or something, I don't know. But anyway, let's continue forth. So I could actually put my answer as 2754.23 to be more exact. 2754.23, and that is also applicable as an answer. So anyway, that resolves that. Alright, you have a nice night.